Hey, this is Emma. We covered the client-server model in an earlier video in this course, but here we'll be looking at it in more detail in relation to some client-server technologies. We'll reduce it to 4 distinct layers, looking at another type of address and define sockets and ports. Just to be crystal clear about the premise of the client-server model, simply, a client device or application sends a request message to the server, and then the server provides the service and sends it to the client in a response message. To talk about WebSockets, we need to first define API, which stands for Application Programming Interface. API is just the term given to the set of tools or protocols or routines that allows one application to interface another, i.e., the second application can access the services of the first. For example, the Twitter API allows you to access tweets and other information to embed into your website or program. WebSockets is an application layer protocol that is an example of an API. It works by creating what is known as a full duplex socket connection between the client, the web browser, and a server using the protocol TCP. Full duplex means communication is allowed both ways, aka bidirectional, and can be done simultaneously. A full duplex connection is in a different context, would be that of a phone call between two mobile phones. This dedicated connection is established on a single socket and through port 80. A key feature of WebSocket is that its packets are usually more streamlined than normal, because less information is needed in the header, effectively because the connection is established already. This reduced size of the packets means you can get much more almost instantaneous real-time data streaming between the client and the server. Time is critical for many web services. For example, a betting company might use WebSocket so they can prevent people betting on things that have just happened. They can't afford for there to be a delay. Databases are so important to networks in the internet, and there is a growing need to be able to connect to database servers and pose web queries to them. CRUD is an acronym representing the 4 fundamental operations that a database really needs to be able to have done on itself in order to be classified as a database in the first place. These are create, retrieve, update, and delete. Create means adding some new data into the database. Retrieve refers to accessing some data. Update is, updating some data currently stored. And delete is removing some data from the database. There are 4 SQL statements that map directly into these 4 operations: insert, select, update, and delete. Our database course will explain how these work with relational databases. Another acronym you need to know is REST, which stands for Representational State Transfer. REST allows web services to make sense of information and allows it to access and manipulate textual representation of web resources using a predefined set of operations. It's simply a design that database systems and applications operating across a network adopt, because it's efficient as it uses elements of the already existingly adopted HTTP. Others exist such as SOAP or WSDL, but you just need to be able to explain REST. In the same way that SQL keywords can be mapped to CRUD, the protocol HTTP has 4 request methods that also map: post, get, put, and delete. These are used when connecting with database servers, but primarily post and get are used, as they can fulfill the functions of put and delete too. For example, post might be used to send cookie data to the server, and get used to receive an image on a website. The principle of REST is creating a separation between the database server and the client browser, because requests goes through a web server and an API. This separation means that both can update independently. So, for example, If some script is executed on the client side, that request data, the API is called through an HTTP request. It's the API that then communicates with the database server, again using HTTP requests. Data is then sent back along the chain in either JSON or XML, which the browser interprets and displays. So, what is JSON or XML? Well, they're acronyms. So JSON stands for JavaScript Object Notation and XML, Extensible Markup Language. They are two common ways of formatting data. This is an example of JSON code. Name and country are the objects, and Arsenal and England, PSG and France, the values of these objects. Compare this with the equivalent XML code. This is a markup language like HTML and uses tags, also like HTML. For your exam, you don't need to know the albeit relatively simple syntax, but rather be able to compare them. Immediately, you can see it much more compact in JSON and easier to read, as you can clearly see how the values relate to these objects, whereas in XML, the tags make it less comfortable to read. When parsed, which is the way of analysing the syntax, the data contained in the XML tags has to be extracted, where it is more clearly defined in JSON. JSON is easier to write and to create, as the syntax is easier to deal with. Writing XML code is more like programming. To sum up, though XML is widely used, many people think JSON is a better option for the reasons I've mentioned. Okay, let's have a recap of what we looked at. Don't forget, a key feature of WebSockets is that its packets are usually more streamlined than normal because less information is needed in the header, effectively because the connection is established already and is used to get updated, immediate information.